In this video, we'll describe how to find the null space of a matrix A. Let's start with the observation that determining whether a vector is in the null space of a matrix is easy. We do the multiplication and see what happens. For example, is 1, 3 in the null space of 1, 4, 5, -1. Well, we multiply the matrix times the vector, and we see that the result, 13, 2, is not the 0 vector. So, no. This vector is not in the null space of this matrix. But how can we describe the null space? A common way of describing a vector space is by describing a so-called spanning set. Recall the following definition. The span of a set of vectors v1 to vn is the set of all the linear combinations C1 v1 plus C2 v2 up to Cn vn. And we will learn how to find a set of vectors v such that the span of v is the null space of A. We'll demonstrate the technique via example. We've already seen this method. I mean, the null space of A is the set of solutions to AX equals 0. And we discussed how to solve this and write the solutions when we discussed homogeneous systems. Example. Find a spanning set of the null space of A, where A is this matrix. So to solve AX equals 0, we augment A with the 0 vector. And then we put this into reduced row echelon form to get this first row gives us this. And the second row gives us this. The third row unhelpfully tells us that 0 equals 0. Our pivot positions are here and here. So our basic variables are x1 and x3. We'll take these two equations and solve for the basic variables. We'll now pad this out by adding equations for the 3 free variables, about which we can say that they're certainly equal to themselves. And we pad this out further by adding 0 terms where terms are missing. We then rewrite this as a vector equation with these coefficients providing the vectors. This vector was a solution to AX equals 0. So these 3 vectors span the null space of A.